Welcome back everyone to another tutorial on Game 5D. In this video, we are finally going to learn about setting up our various LOCOMOTION Interactables and be able to complete the whole LOCOMOTION series altogether. If you haven't watched the previous tutorials, I highly recommend watching them first before continue watching this tutorial so that you would understand how to set up the LOCOMOTION Interactors in the previous video and then come back, watch here to understand how we are going to set up our own LOCOMOTION Interactables. And if you have watched it already, then without any further ado, let's dive right in. Alright, now let's add few of the interactables so that we can actually teleport to. And before that, let me create a quick game object which will hold all the interactables for LOCOMOTION together. And out of the box, Meta only provides us this teleport hotspot and teleport hotspot with a viewpoint teleport interactable, but we also have a few more, and we'll start with the collider interactable at first. So as the name suggests, it's a collider based interactable, and I will create an empty game object under the collider interactable as a child, and I'm going to assign a box collider which will be the surface we will be teleporting to. And let me quickly position the collider interactable to somewhere farther from our origin where we are going to spawn, so that we will have actual distance between the teleportation and we can actually see the arc. And let me add the teleport interactable script because this is required. And as you could see, it requires a surface of type iSurface, and it also has this checkbox which you can use to basically make any interactable teleportable or not. And finally, we have this optionals value which we are going to take a look in a moment. So let's add this iSurface type. Because we don't have an iSurface type, let's assign a script to the collider, and it's called a collider surface, and it exists inside of the teleport or Meta interaction SDK. And as you can see, it's implementing iSurface interface which is required. And let's give it a collider, and that will be our box collider. And while I'm at here, let me also quickly adjust or edit the collider to look like a platform that we are going to teleport at. And that's the flexibility of using a collider interactable, is that any flat surface at any angle, for example, it could be a stair. Let's say if it is a stair, then it will be around almost 45 degrees to 60 degrees rotated, and I'm going to mimic that in here. And collider surface, as the name suggests, provides a way to create a surface out of any flat area you can think of, and you can use that as a teleport interactable to teleport to. So let's drag and drop the collider to the iSurface type, and in order to view an actual reticle appearing to know that where we can actually teleport to, we're going to create or assign a script which is called reticle data teleport. And as the name suggests, it's an reticle data for teleportation, and based on this selection, it is going to send in that data to the actual interactor so that the actual interactor can show the valid reticle or invalid reticle on it. It also has this snap point, and as the name suggests, it can be a transform on the collider where you actually want to snap to whenever you are teleporting to this particular surface. And for now, we are fine with teleporting to any part of the surface. And finally, I'm going to add a visual so that we can see the platform while we are in the build. And also remember to remove any of the box colliders, additional box colliders in the visuals, so that it won't interfere with the actual collider surface that we added. So I'm just making changes to adjust it to appear in the collider bounds. It's very hard to see it from here, but I think it looks okay. So let us quickly change the material so that we can actually see the collider a little clearer. And I think the black one looks really great. And just to make sure we are indeed in the bounds, okay, it looks like we are. Alright, we got our build out, and as you could see, I can see my teleport interactable getting fired, and as long as I'm interacting with the valid interactable, I can see the reticle as well. And as I leave my thumbstick, I should be teleported to the location, and here it is. Let's verify that on our hand interactable as well. So I can shoot the teleport raycast, and as soon as I use the pinch, I am teleported. Great. Alright, we got our first collider teleport interactable walking, and similar to how we show a valid interactable area or teleportable area, it's important in VR for the user to know which area they can actually teleport or not to teleport to. And for that, we are going to use the next set of interactable or teleport interactable called a plane interactable. So similar to that, we are going to add a teleport interactable script. And as the name suggests, it's a plane interactable. We are going to add something called a plane surface. So if you have watched my poke interactable video, you would see, or you would be looking at a familiar infinite plane here. And this is going to be our surface, which we will show the user that this surface or this infinite area is not actually teleportable. And in order to show that, let us move this or rotate this vertical plane to be parallel to the ground or lay flat on the ground. So I'll move it 90 or rotate it 90 on the x-axis, and make sure that this stays below any valid interactable teleport interactable surface that I have, and drag and drop the plane surface to the teleport interactable eye surface group. And lastly, in order to show that the user that this area or this plane is not actually interactable, what we need is that it needs to stay below the surface, as I said, below any valid teleportable surface. And in order to show the actual reticle, we are going to add the reticle data teleport so that we can send our valid or invalid data when the raycast or teleport raycast is interacting with it. And we are going to also make this plane a non-teleportable so that the user cannot teleport to it. And in order to do that, we have this handy checkbox that Meta provides to us, and in here I'm just double confirming that it stays below the surface, and I'll disable the checkbox so that we don't teleport, and I'll also mark the data to be invalid target. So that should show a cross or check mark so that the user would know that this area is not actually teleportable. So let's test it out. Alright, we got a build out, and as soon as I fire my teleport ray, and now I know which area I can teleport and not teleport to, which is much better experience than to wondering why I cannot teleport to these locations. And it makes really clear for the user to know that they cannot teleport to anywhere apart from the platform. And let's verify that with our hand teleport interactor as well. And I can teleport to a valid location, but I cannot teleport to anywhere, and I can see a red mark which was not there before. So that's a better user experience, as I said, for the teleport interactions. Alright, the third type of teleport interactable I wanted to show you is called a navigation surface or Navmesh surface teleport interactable. And as the name suggests, it's going to allow us to create teleportable surfaces out of our Navmesh if baked in our game and app. So I'm going to create an empty game object called navigation surface interactable and assign the teleport interactable script to it. And before adding any other script, we need to first bake in our Navmesh. And to do that, I'm going to create these empty cubes and going to scale it down so that they look more of a path-like structures. I'm going to move it and make it a bit longer. I'm going to duplicate this one and also create another perpendicular path. I'm going to rotate the one around 90 degrees in the Y and move it down so that they look like a cross path. And I'm going to apply the black material to it and rename this to navigation patch. Alright, so I'll leave everything as default. So if you remember, in the past we used to bake our navigation meshes by marking them as navigation static or off mesh navlink static, but things have been changed now with new Unity versions. So now the navigation doesn't exist inside of Unity but rather as a package. So go to the package manager and you need to search for AI navigation, And if you see this AI navigation patch, so make sure you are in the correct release version and not a preview one. Then install it. Okay, once installed, you can also go over to documentation by clicking the link. I'll make sure to leave a link in the description if you want to follow or read anything about the new navigation system and how does that work. And if you don't see this package, you can copy this package name and go to add and add package by name, and after pasting it and select add, you should be seeing it, the package manager downloading it. All right, so let's close this. And now let's over to window, and we don't see the AI button anymore here. The way we can do it is either we can right click on the hierarchy, or in the component menu we can go to navigation, which will be here, and it's now showing in gray, but once you select a game object it should appear correctly. But what we need is a Navmesh surface on our navigation patch. So let's search for Navmesh surface and make sure you select the one with an icon and not the script. So once we have the Navmesh surface, let's add in another one to our next patch. And the first thing that you would see is that we don't have anything baked in, but you would see this overlay menu appearing, and it has these options where you can, once you bake something, you can see all the surfaces using this menu. You can also hide and collapse this menu as a tip. And if you don't see this menu at all, so make sure you are on the scene view, and you can click on the 3-dot overlay menu and select this I button near to the AI navigation, and you should be seeing this panel. Alright, let's head over to the Navmesh surface that we have. The first thing you would see is that the agent type or the area type has been updated. So we now have this new menu called agents and areas, which shows the agent settings and the areas defined. So you can have multiple agents as well. Current one or default one is the humanoid. And if we go back to the inspector menu again, and if we now bake it by default on the first navigation path that we have, and we don't need to select any static anymore, but if we bake it, you see that it's now baking all of the objects which we don't want. And the reason it's doing it is because it's using this collect objects as all game objects, and since this is a linked or touching other game objects, it's selecting everything to be baked at once, and we don't want that. We only want the patch to be selected. So what we are going to do is select current object hierarchy, and if you have physics colliders, or you can select render mesh, and now hit bake. And once you do that, again you don't see anything, and there's a reason for it. And even if I select the physics colliders and clear the bakes and hit bake again nothing happens. And the reason behind it is because our agent currently have a larger radius, and that cannot be than that radius is far more than what it can be baked on this render mesh. So let's head over to the humanoid settings, and in here make the radius to as small as possible, and I think it can go up to 0.05 and nothing less than that. And once we do that, now you'd see that agent looks really small, and now the only thing we have to change is this voxel settings or voxel size. So it will throw you a warning, and make sure you provide a value greater than 0.05 0.22, and it will, now if we do bake, now you should see a navigation patch appearing. And you can also select physics colliders if you want to collider based bakes, and that also working as usual. So for now we are okay with the render measure, so we are going to delete our box collider from each of the navigation patch. And now on the second navigation patch, let's do the same thing. Update the settings, set to current object hierarchy, and bake. Now we got our navigation patch baked in. The last thing we have to do is to, on the root object, we have to create an Navmesh surface, and this Navmesh surface requires an area name for each of your navigation bakes. So for example, the current one that we have is only marked as walkable area, which is by default. You can have multiple areas, and if you go to the area settings, you can have multiple areas, and you can have multiple Navmesh surfaces, an interactable, but for now we only have one. So I'm going to mark or name the area here, and make sure you name it exactly the same, and don't lowercase it, otherwise it may not work. And lastly, to make the reticle visible for the user to know that it's a valid walkable or teleportable area, we're going to attach the reticle data teleport, and make sure you have the reticle mode to be valid target, and we don't want any snap points, and that's it. Now let's test it out. Alright, we got our navigation Navmesh teleport interactable setup, and we should be seeing a valid reticle, and we are indeed. And you can see that plain interactable that we have is correctly showing us the non-teleportable area for the user to have a better experience. I can again go to the collider teleport interactable and move back and forth between each of them. I can also rotate using the turn interactors we had set up, and I can move to any point on the Navmesh surface as you can see here. And now let's try it out with our hand interactables too. So we can make the L shape to get the teleport raycast to be fired, and as soon as I'm doing the pinch gesture, I'm selecting the teleport point. I can also rotate my hand to get the turner interactor to appear, and it's a much better experience now, and that's how we use the navigation teleport interactable. Alright, so the final interactable we are going to take a look at is called a teleport hotspot interactable, and if you search for it, it would be in the same folder as of the interactors, which has been provided by Meta, and this is by far the most easiest to set up. So let's drag and drop it to our interactables, and you would see that it's coming with an collider and a bit of other configurations. First thing is that the reticle data teleport is set to hidden. That means the reticle is not going to appear when we are trying to interact with it. And the other thing is that it contains the collider with the box collider and collider surface, and so it's a type of collider interactable that we saw earlier. And one other thing that the way it works is that it has this animator component which has these clips for hovered and unhovered state, and if we click on the hover and open the animation clip assigned to it, let's drag and drop it into our window, go back to scene view. So the teleport hotspot contains an interactable Unity event wrapper. So that component, if you scroll down a bit, this is the script. So if you look at it, it's listening to this hover and unhover event, and based on that it's playing this hovered animation and unhovered animation. So it's basically making this mesh scale up and scale down, as you could see. So it's making this ring object animated while hovering, and we don't have an unhover script, but rather what it has done, or what normally game developers do, is that you take the same script and make it into a negative, or provide a negative speed to play it in reverse. And that's what the unhovered state is, and it will look like, so if you play the clip backwards, and that's how the unhovered look is going to look like. And this is this game object, that's the ring game object, which contains this mesh that's being animated. So let's quickly place it onto the left side, and I will make another duplicate of it, and I will place it onto the right end. So you already know how the collider teleport interactable work. It's the same thing, it's just the animation that has been added to it, and the reticle data teleport is set to hidden. So it's a bit of learning, you can take it from here. The other variant that I wanted to show you is first let's take a look at the teleport interactable hotspot optional field, and keep a note of these optional fields being empty for the teleport hotspot. The other one that I wanted to show you is called teleport hotspot with viewpoint. So if we drag and drop to it onto a prefab, you will see that it is indeed looks the same, but with a lesser collider size. And if we take a look at the prefab, it's actually a prefab variant from the teleport hotspot. The other thing that has been added is this viewpoint game object, and we'll see what's that and what is the use of it. So as I said, in the teleport with viewpoint, let's open up the optionals in the teleport interactable script, and you would see that unlike the teleport hotspot, these fields have been populated, and the target point has been set to this game object, which is viewpoint, and the viewpoint contains a disabled skin mesh renderer. But if I show you the viewpoint itself has a height of 0.75 in Y, and if we enable the skin mesh renderer pointer, you would see that it's actually a rigged arrow, and it has the skin mesh renderer component on it. So it will play so it's a rig animation, so it will play some animation when we try to point at it. And as I said, the target point is set to viewpoint, and also the tick for face target transform is checked. That means whenever the user is going to teleport to that point, it's going to face to the direction of the viewpoint, and the eye level is also ticked. So that means our camera height is going to be at that eye level, and if you don't want that and only want the rotation to be, you can disable the eye level check from this teleport interactable. And as I said, the viewpoint is pointing into Z axis by default, which is the forward axis. And for now, let me just quickly place it onto this furnitures that we have in the scene, which would be a really good example to show you in what context we should use this viewpoint. And I'm going to rotate the viewpoint to face where an actual user would face when we are normally sitting in this furniture, and I'll make it like -90 in Y. It's going to point in that direction, and the height looks to be much higher than what a normal people will be seeing from a sitting position. So I'll just move it a bit down from what it was. So it was earlier 0.75, I moved it to 0.475, and let me duplicate few of them and place it in these sofas as well. So think of these hotspot with viewpoints are specifically placed in certain position where you don't want user to rotate in other way. So when you want the user to teleport, you want them to look at in a certain direction, and that's where you need to use this teleport hotspot with viewpoint. Alright, we got a build out, and as you could see, I'm using my controllers to teleport. I can teleport to the navigational surface path that we created, and I can use the same teleport interactor, and it's animating to show me that this is the hotspot. And as you could see, I moved to the sofa, but also my height has been adjusted according to the viewpoint we had set. So I also made the second one deliberately much lesser in height, so you would see that again I'm in a much lower height from where I was. And let me see if I can go to the other sofa from here, which will give you the normal height again. So you'd compare that the height of the camera has been changed to match the viewpoint height that you set. Again, also teleport to this separate hotspot that we created, and as you could see that these are the only areas that I can switch to or teleport to. Let's verify that with our hand teleport interactors as well. So if I use my left hand, now I can use the pinch gesture, point and pinch, to know that I can teleport to those locations, and anything else will show you the red marker thanks to the plane interactable or teleport interactable that we added. So this has been a lot nicer experience from what we have been trying to achieve here, and I think this is by far the best implementation of teleport interactors by Meta throughout the whole Meta XR interaction SDK timeline. And that's all to it. If you have been watching this far, hope you found this video really helpful, and now you should be able to create your own locomotion interactions using the information I shared with you all in this video. If you like this content, please consider leaving a like and also subscribing this channel for more content on VR development. That will not only help the channel to grow, but will also help me motivate to come up with new VR development videos throughout the time period. And if you like to get notified about any new video release on the channel, consider clicking on the notification bell. Thank you for watching, and I'll see you in the next one.